Hi class. So today we are going to do a quick review of notes for quadratic functions. Like I explained in class today, we are going to be really looking at the graphs of quadratic functions and then also applying what we know with quadratics to word problems. So none of this should be new. It should be easy, and we will jump into the word problems together in class this week. But for now, what I would like you to do is just get through these notes with me. So real quick, we talked about different types of functions already. We have a linear function, which is f of x equals ax plus b. We have our constant function, which is just f of x equals c, so c being any number. And then we have a quadratic, where we have our f of x equals x squared. We also talked about standard form already. You should know this form. Ax squared plus bx plus c. So the graph of a quadratic is a parabola, and if the leading coefficient of the quadratic function is positive, it should be opening up. Therefore, you're going to have a vertex, such as in this picture. Here's your parabola opening up. You're going to have a vertex that's down here, which means your vertex is a minimum. It's the lowest y value that you can have on the graph. Whereas the reverse will happen if the value is negative. So then the graph would open down. So if I can just give you a little picture of that. The graph would then open down something like this, where your vertex is now a maximum point, approximately there. We also talked a little bit about the a value, and the a value tells you whether the graph is going to stretch or shrink vertically. Absolute value of a is technically what we're looking at, because whether it's positive or negative is only going to affect whether it's opening up or down. But the actual value of a will tell you whether it's stretching or shrinking, which we talked a lot about in the previous section. So you have two examples which are not actually on my slides here, so we're going to add another page here. So you have two examples on your notes sheet. A equals a negative 5, and then you also have a equals 1/2. So let's talk about these. Technically, if we're looking at a values in standard form, we're always talking about a vertical distortion, whether it be stretch or shrink. So if you think about the absolute value of a negative 5, you're thinking about just the whole number 5. So the whole number 5, hopefully you're remembering this, should be a vertical stretch. And basically the negative is just telling you that it is reflecting the x-axis. The next example, 1/2, the absolute value of 1/2. Again, we're saying it is a vertical, but only this time, technically the picture is getting wider, so vertically it is shrinking or compressing. So another word that you're going to hear a lot in this section is just compress. It's just another fancy word for shrink. Okay? Again, nothing new. So let's also take a look at vertex form. So vertex form, we dealt a lot with in this past section looking at transformations. So again, A represents the width of the graph. The H and the K tell you the vertex coordinates. And whether it's shifting left, right, up, down. Something that we haven't discussed yet, but I know you talked about in Algebra 2, is axis of symmetry. Axis of symmetry is basically just the x value of your vertex. But it is a line, a vertical line. So when we are asked for the axis of symmetry, we need to give an equation, a linear equation. So the linear equation is always going to be x equals whatever that h value is. And it's basically a vertical line through which, through the vertex, about which the parabola is symmetric. So on left and right, you will have symmetrical points. Talked a lot about vertex already, but again, just to reiterate, vertex is the specific ordered pair h comma k. It tells you the maximum or minimum value, y values of a parabola. Y value of a parabola. And to find the vertex, if you are in standard form, is opposite of b over 2a, and then take that value that you found as your x or h coordinate, plug it back into your function to find your y coordinate. All pretty basic stuff, which we've talked about. Next, let's talk about x-intercepts. So these are all essential pieces for if you're wanting to graph a function, a quadratic function. So if you are looking for x-intercepts, you have two ways of solving. You can either factor and then solve those factors when the function is set equal to 0. Or if the function is not factorable, then you can use the quadratic formula listed here, although we should all have that memorized by this point in your math career. And the last piece of our notes here before we do a couple of examples is completing the square. So we have done a little bit of this already. Completing the square is basically the process used to change a function from standard form to vertex form. So let me just get my pen again and we will do an example here. If I want to change this function to vertex form, I want to start by moving my constant to the other side. So I'm subtracting 3 from both sides. Oops, minus 2x, sorry. And then we want to take b divided by 2 and square it. So this is your b. So we have a negative 2 divided by 2, and then we are going to square that answer. So that's actually going to give us negative 1 squared, which is just a positive 1. So that value is going to be added to both the left-hand side and the right-hand side. Now we want to simplify. So this is going to end up giving us minus 2. And on the right-hand side, we do want to factor this. So this should be a perfect square trinomial, which means it should factor nicely to x minus 1 squared. And then the last piece is just get that f of x by itself. So move the 2 over by adding. Again, this is a process that we've done already in this class. Hopefully we remember, because you did have to do it on your test. So hopefully you were okay with that. Okay, so what I'm going to do now is, I'm going to walk you through 2 of the examples on this page. Any of the examples that I am not walking you through right now, you can skip and hang on to. We'll do tomorrow in class together. So we're going to do number 1. It says find the vertex, axis of symmetry, and x-intercepts of the following function. Then write the function in vertex form. So we got a lot of things to do here. So first thing we want to do is find our vertex. So our vertex is the opposite of 8 over 2 times 2. So that is going to simplify to a negative 2. I'm going to take negative 2 and plug it back into my function. Remember, do not make any silly mistakes. Follow PEMDAS, because you do want to square the negative 2 before multiplying by 2. So squaring that gives you 4. 4 times 2 is 8. Then we have minus 16 and plus a 7. So therefore, that's going to give us a negative 1. So your vertex is the ordered pair negative 2, negative 1. Axis of symmetry, as I mentioned before, is a line. So you need to give me a linear function for that. So a of s. And it is actually just going to be whatever the x value is in your vertex. So x equals negative 2 is the line for your axis of symmetry. Last piece is, not the last piece. Next piece is finding the x-intercepts. So in this particular problem, I'm not seeing it as easily factorable. So if it's not easily factorable, just go ahead and do the quadratic formula, and that'll give you your answer every time. So negative 8 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So you can go through this, simplifying everywhere that you need to. I'm just going to jump right to my answer. So this should end up giving you 2 answers. You're going to have a negative 1.29 approximately as one intercept, and your other should be negative 2.71. Whoops. Come on, 0. So there's your 2 intercepts. So right now you already have 3 points that you could plot if you were trying to graph this function. Last step is to write this in vertex form. So remember, with vertex form, move your constant first. And then this one is slightly different than the last one. When you are finding vertex form by completing the square, you do need to remove the a. So factor out the a as your second step here. So if I factor out an a, my a value, which is a 2, I'm left with x squared plus 4x. And because I did that, when I go to find that new C value over here, I'm actually doing 2 times that is being added. So here I need to do 2 times whatever it is that I end up adding. I'm still going to follow that process of b over 2 squared, but I'm using this b now. So b divided by 2 is 2, and then 2 squared is 4. So I'm going to put a 4 in here, but technically I'm not adding 4 to the right-hand side. I'm really adding 8 because I'm doing 2 times the 4. So I'm going to add a 4 in this spot here, showing that I'm going to really add 8 to this side. And we can discuss this further in class tomorrow if you are not grasping this. So now I combine like terms on the left-hand side. On the right-hand side, I'm going to take that trinomial that's in parentheses, and I'm going to factor that down. That's going to give me x plus 2 squared. Then I'm going to move that 1 over, and my function is 2 times the quantity x plus 2 squared minus 1. So this is the vertex form of this function. Again, we'll talk more about the completing the square and factoring that out that a tomorrow if you need it. So just make sure you have all of this copied down. You're going to skip the next one. We'll talk about that in class together tomorrow. And let me just show you an example of number 3 here. So number 3, it says, writing the standard form of the equation of a parabola whose vertex is 1, 2, and that passes through the point 0, 0. Now, technically, you actually did this already on your test. Basically, what you need to do is find an a value, and then once you find that a value, you can put it into vertex form and then expand it out into standard form. So if you have, actually, let me label these first. So you have h and k here, and you have x and y here. So 0 equals a times x, which is 0, minus h squared plus k. So I'm moving that 2 over, so it becomes negative 2 equals a times negative 1 squared. Negative 1 squared is just 1, so basically a is just a negative 2. So that means if I were to write this in vertex form, it would be f of x equals negative 2 times x minus 1 squared plus 2. This is me just filling in a, h, and k. If you go ahead and expand this all out, you're going to have negative 2, and then this expands out to x squared minus 2x plus 1, and then plus 2 at the end. Remember, order of operations, distribute this negative 2 to everything in the parentheses, then add the 2. So we get negative 2x squared plus 4x minus 2 plus 2. These last 2 terms are going to cancel. So in standard form, we have f of x equals negative 2x squared plus 4x. So hopefully none of this has been new. It's just a quick review. I apologize if I'm talking very quickly as well on this. I'm sorry about that. All the rest of the problems, so 4 and 5 and then the application word problems, you can skip all of them, and we'll do in class tomorrow together as an extension of our notes for this section. So if you can just stop at number 3, make sure that you've gotten all of the notes that are necessary up to this point, and let me know if you have any questions tomorrow when you come to class.